question we're looking at told us that 1% of the population has the antibodies. Okay, so we're going to start by making a tree diagram, and we're going to see what we end up with. So we're going to have a little guy here, okay? Here's a little guy. And he either has antibodies, it says antibodies. Well, it doesn't say it very well. Let's make that. Okay. How about we do this? How about we label that present. Either the antibodies are present or the antibodies, I lost my color, are absent. I wanted my green back. Oh well. The antibodies are either present or absent. And since we're told that 1% of the population has the antibodies, the probability is 0.01 that they're present, 0.99 that they're absent. And if they are present, you can either test positive or you can test negative. And if they're absent, you can either test positive or you can test negative. And the chart tells us that if you do have the antibodies present and you test positive, the probability of that is 0.9985. And the probability of testing negative is 0.0015. The chart also tells us that if you have antibodies absent, you test positive 0.0060 and you test negative 0.9940. Okay? So those four numbers I just pulled straight off the table. The 0.01 and the 0.99 are from the information given in the problem that 1% of the population has the antibodies. And the way the tree diagram works is that we are going to just multiply straight across. So we'll multiply the 0.01 times the 0.9985, and here we will get 0.009985. We'll multiply the 0.01 by the 0.0015, and we'll get 0.000015. We'll multiply the 0.99 by the 0.0060 and we'll get 0.00594. And for the last one, we'll multiply 0.99 times 0.9940 and put 98406. Okay, so what are we looking at now? We want the probability that the person has the antibodies given that the test is positive. Well, which of these in this column represent where the test is positive? This one, positive test, and this one, positive test. So that's going to be our denominator. We're going to add those two numbers together, because that's going to be all the possibilities where the person's going to test positive. If we add those together, we get 0.015925. Okay? And out of that, so given that we've narrowed down to just those two possibilities, this or this, okay, and we've given that into the denominator. Given that constraint, what's the probability that the person has antibodies present? So we're going to take that number, 0.009985, as our numerator. So this fraction right here is going to give us our probability. Let me grab another color that I haven't used so I can set it apart. I'll use bright blue to set it apart. So what we do when we divide that is we get 0.627. That's the probability that a person actually has the antibodies present given that they had a positive test.